So this is big idea number 4, which focuses on algorithms. This is the practice question series in preparation for the AP Computer Science test. So let's take a look at these questions. All right, question number 1. This is very wordy, so let's take a look, see what we can do. So a car repair chain is creating a new program to offer discounts and incentives to its customers through a series of memberships. To qualify for silver, a customer must visit the chain at least 3 times. So must visit greater than or equal to 3 times and spend at least $150. So greater than or equal to 150. This is dollars, and this is visit 3 times. All right, to qualify for gold, they must visit at least 3 times a year. So again, greater than or equal to 3. And they must spend at least 120. Sorry, at least 200. And to qualify for platinum, they must visit at least 3. And they must spend at least $500. All right. It says they have a list which includes customer names, customer contact information, number of visits per year, good, because we need it to be at least 3, and then the total dollar spend for last year. And so we need this to be between 150 and 500 to have them in one of these membership packages. So it says, which algorithm, if any, can the chain use to identify the members from a list of customers? So in algorithm 1, it says you can filter the data by creating a new list called list 1 of only customers that have spent $150 or more. Okay, and it says create a new list, platinum, and then if a customer on list 1 has spent 500 or more, then they go onto the platinum list and they get removed from list 1. All right. So far what I'm noticing is that this is not checking if they have visited at least 3 times. So that's something we've got to be careful about. But it does get the more than 500. And then it says create a new list gold. If a customer on list 1 has spent 200 or more, add them to gold and remove them from list 1. Okay, so then the gold membership more than 200 have moved over. And then it says filter list 1 by creating a new list, silver, of only customers that have visited more than 3 times in the last year. So this more than 3 times in the last year, this is only done to a subset of these groups. It's not done to the ones that we've already put on the platinum list or the ones that we've already put on the gold list. This is just done to the remainder. So algorithm 1 is not working for us. Okay, algorithm 2. Let's come up here, change the color. It says filter the data by creating a new list called list 1 of only customers that have visited 3 times or more. So that's good. So list 1 has now got only the people with visits of greater than or equal to 3. So that means that it's checked this, it's checked this, it's checked this. List 1 contains all of these people. Or more in the last year and have spent more than 150. Now, this is where I don't really like this question too much, because I know that the answer in the guide says that algorithm 2 is correct, but technically, if we filter this list to only show people who have spent more than $150, then this is ignoring the people that have spent more than or equal to 150 because it's ignoring the people who have spent exactly $150. And if they spent exactly $150, they should be included in the silver package. So this is a mistake of this question. This should say at least or more than or equal to. So let's go with what they were really meaning, which is at least. So if this list shows everyone that has visited at least 3 times and has spent more than or equal to $150, then that's definitely going to give us all of these people right here. So then the next step would be create a new list called Platinum. And then if a customer on this list, list 1, has spent 150 or more, notice how it's including the or more for those who have spent exactly 500. So this is 500 or more, and it's including those people who have spent exactly 500. And then it says add those customers to the list Platinum and remove them from list 1. And then create a new list Gold, and if a customer on list 1 has spent 200 or more, add them to Gold and remove them from list 1. And then all remaining customers on list 1 are Silver members. So this one does make sense, is true, algorithm 2, as long as we take care of this more than 150. So therefore algorithm 2, and that would be B, which would be 2 only. Okay, so that was question number 1. All right, let's head over to the second. So this is the second question. Let's take a look. So it says the following code segment finds the sum of all numbers num in list numList. Okay, so here we've got a few things. The sum is given a value of 0 to start off with, and it says for each num, for each number in this list, take the sum, which to begin with is 0, and then give it the value of 0 plus whatever, and this should really say num. So this is another mistake in this textbook. So for each num in the num list, the sum, which happens to be 0 originally, is given the value of 0 plus whatever that number is. And then it will repeat for each of these numbers. So now the next number would drop in, and now the sum would be different, and then we would assign the value of the sum plus the new number, and that would just keep going around. So, and it says the following code segment finds the sum of all numbers in the num list, so it's just adding them all up. Next, what code segment will find the product of all numbers num in the list num list? All right, so this time we're dealing with products, so we're dealing with multiply. Let's take a look at A. The product is given the value of 1. For each num in num list, the product is assigned the value of the product plus the number. Well, that's not multiplying everything out, so it can't be A. In B, the product is given 1, and then for each num in num list, the product is assigned the value of product, which in the first case is 1, times by the number in the list. And that kind of makes sense. So 1 is times by the number, and that's now the new value of product. And then it repeats, so it comes back up for the next one. Now the product is product times num, and that's being now given the value of the product, the answer of that, times by the next number. And that keeps happening. So B is going to effectively do exactly what we want, and it is identical, except it uses multiplication instead of addition. So we could keep going through these others, but we know the answer is B at this point. There's issues with how C is written. We've got this parentheses here and repeat until, and this is going to be a number. So if the list was 5, repeat until 5, what does that mean? So there's many issues with C. And then D, repeat length num list times. So if the list had 5 there, and then the product is being assigned product times num, but we don't know what the product is to begin with. Whereas in B and in A, the product is given the value of 1. So this is not the answer. So B is going to be our answer for number 2. Okay, question number 3. So it says, list my list contains integer values. So integers are numbers that are negative and positive whole numbers. So if we just use this and pretend that this is my list, this is called my list, and there's 5 digits here, 5 numbers, and it says which of the following code will remove all negative values from the list. So in this case we would want to remove the -2 and the -1. Okay, so the first example, I is given the value of 1, and then we're told repeat length my list times. So in this case, length my list would be 5. In my example, 1, 2, 3, 4, 5. We've got 5 items, so the length of that list is 5. And it says if my list I, well, the first case, I is 1, we're told I is 1, so my list and then 1, this is going to be the value of the first, number 1, this is going to be the value of the first item of this list, which is -2. So it says if my list I, which is -2, is less than 0, which it is, then we need to remove from my list that I. So item 1 from that list gets removed. So that's good, it did work the first time round. And then it said give I the value of I plus 1. So now this becomes my list 2. So now we're looking at the second item. But there's a problem here, is because if this first item goes, then we're just left with -1, 0, 1, and 2. But now if we try and look at item 2 of this list from my list, now we're going to be checking this, but we're ignoring this very first one. So the problem when you remove an item from a list, if you remove it from the front of the list, everything moves down. And so if item 1 disappears, there's a new item 1. Everything's moved up. And so we end up ignoring running this check to remove a negative integer from the first item. So therefore, algorithm 1 will not do the correct thing. Okay, so for the second algorithm, it says assign I the value of length of my list. So if we are sticking with -2, -1, 0, 1, 2, this is 5 items on this list. So I would be given the value of 5. So it says repeat length my list times. So repeat 5 times. Okay. And it says if my list I, so that's the 5th item, is less than 0. Well, this item here is not less than 0, so we're not going to remove it. But then I, which was 5, because it was assigned at the beginning, is going to be given I minus 1. So now the new value of I is 4. So then we come back up to repeat this again. So if I is 4, we're now going to look at the 4th item. And we're going to see, is that less than 0? And it's not. So then we're just now going to look at the 3rd item. It's not less than 0. And then it goes around the top. Now we're going to look at the 2nd item, -1, which is less than 0. So that does get removed. And now everything moves down. But because we were just looking at item 2, when we do this -1, we're now looking at item 1. So we're now so everything gets checked, and this is less than 0, so that gets removed. Everything gets checked. So algorithm 2 is working correctly because it's working from the very end of the list. So algorithm 2 only is the one that works for question number 3. Okay, question 4. All right, so in this question, consider the program that attempts to store the sum of all elements in list A that are greater than the previous element. So if we take a list like 2, 4, 3, 5, if this is our list of 4, it wants us to sum all elements in the list that are greater than the previous element. So if this is greater than this, it's going to be on our sum list. Now 3 is not greater than 4, so that's not on our sum list, but 5 is greater than 3, so that goes on our sum list. So we would add the 5 and the 4. So let's see how this is working within the code. It says I is given the value of 1 and sum is given the value of 0. And it says repeat until I, the value of I, is greater than the length of list A. So in my example up here, item I is greater than the length of list A. Well, list A, the length of it is 4 because there's 4 items. And at the start, item I is given the value of 1. So it's checking, is 1 greater than 4? No, it's not. So then it keeps running this. So then it says if list A and then I, so if the first item of list A, which is up here is this 2, is greater than the I minus 1 value, which is the 0 item, which is, well, it's not there, so that's not going to work. So, this is where we have our first dilemma, is because should we really be checking the first item on the list to see if it's bigger than the one before when the one before doesn't even exist? So maybe we shouldn't start with I is given 1, but if I change this color, maybe we should be starting with I is given the value of 2. So what that does is we now have a 2 here. So if that item, if 2 is greater than the length of the list, which as this increases each time, we would need that 2 to be a 5. So we've got to be a little careful about that. But anyways, if list A and then these brackets and then 2, so that's the second item. So that's talking about the 4 right now. If that 4 is greater than the previous item, which is the 2, so if the 4 is greater than the 2, then the sum, which currently is 0, is given the value of 0 plus, and then we need it to add the 4 because we're doing the sum of these things. So we need to add not list A I minus 1, but just the I, the value of that I place right here. So we're adding the 4. So as we look at this, and then actually if we just talk through the rest, then after it adds that, we need to increment the value of I by 1. So that I, which if I change over to blue, that I, which is currently 2, ends up having 1 added to it. So now it becomes 3. And then it runs through the third item to see if that's bigger than the one before. And then it will run through the fourth and so on. So the 2 changes that I made were this. I must be given the value of 2. So that's the first correction. Choose 2 corrections that must be made in order to make the code run as expected. So that's the first one. And then the second one is that line 5, which is sum is given sum plus list A, and then this stuff, oops, right here, then this stuff should really be list A brackets I. So this one here. So our answer for question number 4 is A and C. A and C are the answers. Okay, question number 5. Okay, so the halting problem is a problem which decides whether or not a program will run forever. Sometimes it's easy to determine whether a program or not will run forever. Computer scientist Alan Turing proved that there is no algorithmic solution to the halting problem that works for every algorithm. What is the halting problem an example of? All right, so this was in some of the notes that we looked at in school, and basically the halting problem is an example of the undecidable problem, which is right here is A. And how this works is that there is no algorithm to give a yes/no for all instances of a problem. So the undecidable problem is where there's no algorithm to give a yes or no answer. And so that is what this is an example of. So that was question number 5. Okay, number 6. Okay, so the question below uses simple programming language with the following instructions. The following program displays whether a number x is even. Okay, so if x mod 2 equals 0, so remember that mod divides the numbers and finds the remainder. So if x was an even number like 6, 6 mod 2 would be 3, the remainder would be 0, and 0 does equal 0, so it would display even. And then it says if not x mod 2 equals 0, so if x mod 2 doesn't equal 0, then we do not know necessarily that it's odd because it could be a decimal. However, we do know that it's not even. So if x mod 2 does not equal 0, then it displays not even. Next, it says choose 2 things that are true about the above problem. Okay, so the program uses Boolean Algebra. So Boolean is kind of like the logic that we looked at in geometry, where we deal with negation, ands, ors, etc. And so because this has a not, and we look at some other operators, this is true that the program does use Boolean Algebra. Okay, the program demonstrates a binary search. Well, that's not happening. It's not doing a binary search where it splits the data into 2 and then keeps searching and keeps splitting into 2. That's not happening. Okay, the program for certain values of x will display both even and not even. Well, I can't think of a case when that happens. Either it does equal 0 or it doesn't equal 0. So that's not happening. And then D, the program provides a definite answer to the question, is x even? It does. It either says it's even or it says it's not even. So the answer is A and D. We just checked back, it does say choose 2 things. So that was question number 6. Okay, 7 is here. It says, how is the correctness of an algorithm determined? So when we deal with algorithms, and we looked at this in our curriculum, algorithms are usually using math and logic as part of their determination. So as I look through all of these answers, answer B says reasoning formally, so reasoning is the logic part, formally or mathematically about the algorithm. That is how the correctness is determined. So B is our answer for question number 7. Okay, question number 8. So this says a mobile application developer wants to create a wardrobe app. She wants her app to offer clothing suggestions for the next 4 days based on weather predictions. Okay, of the following choices, which is the least difficult, so the easiest way to connect weather predictions to her app? So she could research meteorology, update her findings daily, push out updates. Okay, so this really isn't sounding easy, so not going to be this. Okay, B, learn about which weather models are most accurate for a given region. Replicate the models, use a phone's location. Okay, so all of this stuff could be done, not really seeming easy or accurate. Okay, C, obtain and work with an API from a trusted weather forecaster's website to use their predictions as parameters for the wardrobe suggestions. This is going to be our answer. Whenever we need to connect to some real-time data and other people are producing that, we can use an API to connect to that, to pull that information. So as they update it, we can get those automatic updates, and then we can link to that information via the API to complete the tests of the app. So C is going to be our answer. Okay, and even D is hiring a meteorologist. That's not the least difficult. So the least difficult is just connecting with code to the API. Okay, question number 9. Okay, so a computer science workshop presenter wants to write an algorithm to pair up participants based on birthdays. First, she wants to create pairs of participants with the same birthdays. She will pair up any remaining participants by finding the person with the closest birthday. Which of the following algorithms will correctly find pairs of participants with the same birthdays? Select two answers. So we are looking for pairs of participants with the same birthday. All right. So let's go through each of these. So A is saying make a copy of the list, call it copy. Select the first person on the copy. Complete a linear search. Well, a linear search is where you take that item and then you go through each item on the list and see if it equals. See if any of them are matching. Okay, and it says complete a linear search to find someone else with the same birthday. And then if there is a pair, save the pair to a third and final list called pairs, and then remove both people from copy and go back to step 2. Now the problem here is that if they don't find a pair, they don't remove anyone, and then if you go back to step 2, you just select the first person on the list and you already search for them. And so if there's no copy or same birthday, then we just keep searching the same person. So the answer does not include A. So now B, select the first person on the participant list. Complete a linear search of the participant to find somebody else with the same birthday. If there are more participants on the list, repeat steps 1 and 2. So in this case, again, we're selecting the first person on the list. We're doing a linear search to find somebody else with the same birthday. And then if there are more participants on the list. So here it looks like there's less detail, but it is finding the match. And then after it's found the match or not, so it either the match could be a yes or no, but after it's done this, whether it's yes or no, if there's more participants, it's then going to repeat it. It's going to find a match. So it's doing this through a linear search, just like we've shown here. But if it finds a match, great, and then it keeps going. And if it doesn't find a match after the linear search, and the linear search checks all of the rows. And once it's done that, it's then going to do the same over. So B is one of the two answers. And then for C, it says make a copy of the list, call it copy. Sort copy by birthday. So it's arranging everything by birthday. Save every 2 consecutive participants into a new list called pairs. Well, just because they're consecutive doesn't mean that the 2 birthdays that you've got are going to be the same. So this isn't doing what the question is asking, which is which of the following algorithms will correctly find all pairs of participants with the same birthdays. It's not doing that. It's finding other things. It's finding just the birthdays that are next to each other, which don't always have to be the same birthday. So it's not C. So because it says select 2, we already know it has to be D. And if we were to read through this, we'll see that they're making a copy, they're sorting it by birthday, and then it's saving every 2 consecutive participants onto a new list called pairs, and then select the first person on the list, complete a binary search, so that's where it's splitting the list into 2 and then checking. And then if there are more participants, repeat step 1 and 2. So the answers are B and D. And we knew that just after we eliminated C as well. Okay, this is the last question on big ideas, number 4. And this is question number 10. It says a student notices members of the community are throwing recycling materials into the trash. He decides to create a mobile application to allow users to photograph an item, and the app would return information to the user about whether or not the item is recyclable. So before we keep reading, let's think about what his app's doing. His app is on the cell phone, you take a picture, then somehow connecting to some of the data, the cell phone through the connection will identify the object, will identify the material, and will know if it's to be recycled or not. So it says, as he creates his program, he realizes that the recycling programs can be confusing due to different procedures in different communities. He also begins to see a pattern in images that help him determine if the item can be recycled. What is one of the possible explanations for what the student has learned? So A, developing a new algorithm to solve a problem can yield insight into the problem. Well, that's exactly what happened. As he started to understand this problem and work on it, he then had these noticings about the patterns in images and also the differences in the requirements on each community in terms of what to recycle and how to recycle it. So we already have our answer of A.